What is etcd in Kubernetes architecture? Imagine a busy city where every building, street, and traffic light depends on a central map to stay in sync. In Kubernetes, that map is etcd. It's a special kind of database that keeps track of everything happening in the cluster. Think of it as the ultimate record keeper for all your cluster data. It stores information about how your applications are configured, what state they are in, and details about all the objects like pods, services, secrets, and configuration maps. Without etcd, Kubernetes wouldn't know what your cluster looks like or how it should behave. In Kubernetes architecture, the control plane is like the brain that makes decisions for the cluster. It includes components like the API server, controller manager, and scheduler. These components are all stateless, meaning they don't keep data themselves. Instead, they relying on etcd to hold all the important information. When you create or update a pod or service, the control plane writes this data into etcd. When the control plane needs to check the current state, it reads from etcd. This setup makes sure that all parts of the cluster are working with the same information. etcd uses a method called the Raft consensus algorithm. This helps keep data consistent across multiple nodes. Usually, etcd runs as a cluster with an odd number of members, like 3 or 5. Having an odd number helps the cluster stay available even if some nodes fail. For example, with 3 nodes, if one goes down, the other 2 can still keep the cluster running. But if 2 nodes fail in a 3-node setup, the cluster can only read data but not make changes. This setup is common in cloud environments like Amazon Web Services, Microsoft Azure, or Google Cloud. etcd stores data in a way that keeps track of every change made. It creates a new version of data each time something updates. This is called multi-version concurrency control. It helps Kubernetes controllers see what has changed over time and fix any mismatches between the actual and desired states. To prevent data from growing too large, etcd periodically cleans up old versions through a process called compaction. But if your cluster is very busy, monitoring etcd's health and storage is important to avoid issues. Managing etcd properly involves making sure it runs on machines with enough resources. Disk speed and network quality matter a lot because slow disks or high latency can cause delays or instability. Regular backups are a must because losing etcd data means losing your entire cluster state. Automation tools can help with deploying, scaling, and backing up etcd, especially in large or multi-cloud setups. Security is also key. etcd should use transport layer security to encrypt data in transit and restrict access to authorized components only. Keeping etcd updated with the latest stable releases helps protect against vulnerabilities. In the end, etcd is the core of Kubernetes control system. It holds all the information needed to keep your cluster running smoothly. Proper management of etcd ensures your cluster remains reliable, secure, and ready to handle changes. Whether you run Kubernetes on your own servers or across multiple cloud providers, understanding and maintaining etcd is essential for a healthy, scalable environment.